One.
Hi, thank you for joining us today. We are Team 12, and my name is Derek Walsh, and I'll be providing you with a project description. Brian Behringer will be providing us with intended users and the background of our project. Kyle Smith will be providing us intellectual property issues that we may encounter. Joe Lassacasas will be providing us with ethics and some concerns we had. And finally, wrapping us up will be Nikita Mikhailov with a final concept and review. Our mission here is to provide to the masses of buyers and sellers of vegetables and fruits a portable handheld device that's capable of scanning various fruits and vegetables to determine their freshness and consumability when you scan that product. We plan on utilizing two forms of technology, mainly near infrared light to scan and analyze the fruit, and we'll be utilizing artificial intelligence to analyze various data that we will collect throughout this project to help us create an index that we can then cross-reference with said scanned data to provide an accurate and concise answer for consumers and buyers to make a right choice with the fruits and vegetables they have. So why do we need such a device? Why do I, a buyer or a seller, need this device? Well, honestly, I think I can speak for all of us when I say that we have been dissatisfied with either wasting our produce or failing to have a good buying experience when we go to the store and we buy something and it's not fresh, it's not good, it's a waste of time, it's a waste of money. But that's where our scanner comes in. This will solve all those issues in a non-destructive manner by analyzing various components of those fresh produce and vegetables, such as moisture and sugar content, in seconds and provide you with a answer. And we would like your help by supporting us throughout this project to help us with criticism and questions and give us feedback. We'll review all your support and ensure that every part of this is a fresh evolution. And I will pass this off to Brian Behringer.
Hello, my name is Brian Behringer, and I'm going to be presenting the background portion of our project. So firstly, why did we choose the fruit scanner? So we started off by exploring different possible directions that we could take this project. We took a look at a sponsored project list and we brainstormed a couple of ideas on our own. We really had a goal to create something that was impactful, not just innovative. Some of the ideas had really cool technology involved. They had really good ideas. However, they didn't really match with the goals we had in mind, principally problems that people actually face on a day-to-day basis. So for this product, our intended user are farmers, grocery stores, and food suppliers. Our product essentially scans produce to see if it's still fresh. This can help save a lot of waste, especially in places like grocery stores, where millions of pounds of produce are thrown away on a yearly basis just because of not being able to detect the freshness. So we took a look at a couple of projects before we chose this one. To start off, we had a robotic puppy idea. We would load this puppy with sensors like radiation detectors. Even though it was a really good idea, it really felt like a tech demo without a clear use as to where we were going to take it. Secondly, we thought of a security camera project. However, this product already has a well-established base, and there's not really much we can add to it. So we did not choose this idea either. Ultimately, we went with the fruit scanner. It checked all the boxes. It's consumer-based, and it's easy to adapt to multiple markets. It also saves a lot of waste. And with that, I'll pass it on to Kyle.
Thank you, Brian. So, my name is Kyle Smith, and I'll be talking about intellectual property. So, why does intellectual property matter here? When we're talking about intellectual property, we're talking about copyrights, patents, company secrets, and these are based off of designs or ideas that are already covered under legal coverage. So when we're talking about fruit scanners, we're going to scan the market and see what are the existing products or existing patents or copyrights so that we're not copying an existing project. So our first number one is the non-destructive fruit firmness tester. And this is US patent 5372030. And this is going to encapsulate firmness testing by mechanical pressure. It is going to press the fruit, not so much that it breaks, but just that it detects the ripeness. So we as a group are going to avoid copying this project because we're not going to be really using any sort of mechanical pressure to gauge the fruit's or produce's freshness. Next, we're going to have patent number two. And this is a little bit closer, it parallels us a little bit closer because we're going to be also using near infrared detection. And this is the near infrared spectroscopy for the ripeness detection. And it's US patent 10839-503B2. And this applies the near infrared detection and it pairs it with their own type of algorithms that help them classify the internal fruit quality. And one way that we're going to try to avoid, again, mimicking this product is by using different spectral bands and different versions of visible light or multispectral imaging so that we can create our own version of produce scanning. And then lastly is patent number three, and this is a European avocado scanner system. And this is very niche. It only scans avocados, but again, it uses that near infrared and hyperspectral imaging to detect the produce's freshness. So, in summary, the ways that we're going to avoid patent infringement is mainly by the fair use doctrine. And what this is going to allow us to do is we're coming from this as the perspective as students from an educational research standpoint. We won't be releasing this into the market. This isn't an intended product that we want to get patent. This is just strictly an educational use. So that's going to allow us to avoid copywriting and a lot of the patent infringements. And that's also going to allow us to reverse engineer some of these existing products that might help us in our project so that we can create an effective product. And it is also a freedom to operate. It depends on the sensing and the modularity and the different software. So, like it's been already discussed, we're going to try and integrate AI to help us to detect where the fruit is in its freshness. And that is all for intellectual property. And I'm going to pass this on to Joe.
Thank you, Kyle. My name is Joe Lascasas, and I'm going to be talking to you guys about our ethical considerations or show you how our produce scanner tackles a real-world problem undergoing an ethical and transparent approach, one that reflects our vision of responsible innovation and a better quality of life. Number one, our scanner uses near-infrared spectroscopy and AI to analyze fruit freshness, but with that power comes responsibility. The data it gathers, if misused, could unfairly grade produce, putting small-scale farmers and retailers at a disadvantage, and increasing unnecessary food waste. And while we trust our technology, it's still emerging, still new, we're human. Mistakes can happen. And we don't want users to lose touch with their natural ability to judge freshness. Our solution is grounded in transparency and trust at first. Data is never collected without the user's permission. The software and AI models are open source, allowing anyone to inspect or improve upon them with the appropriate considerations. We also provide educational materials, guides, documentation, so users can understand exactly how the scanner works and even repair it on the fly if need be. We're not just building a tool here, we're cultivating informed and capable users. So, what is the good life? For our team, the good life isn't about replacing human effort with automation. It's about enhancing it. We believe in a world where users are empowered with knowledge and not left in the dark. Our scanner doesn't just help people choose fresh produce, it supports sustainability, reduces waste, and ensures that innovation remains accessible, ethical, and meaningful to all. So, on the recap, we're addressing a common need with cutting edge technology, but we're doing so as ethically, transparently, and with the user in mind. I'm going to pass this off to Nikita, who's going to close this out.
Thank you guys. I'm going to cover the concept selection process. The items you see here are essentially our non-negotiables when it comes to considering the design. As far as which I would consider are the most important, although they all are, we want this design to be portable. We want it to be efficient and accurate. We want it to be safe. We want it to be affordable. What you see here is the model that we are going to be observing throughout our design. There's a light source that's going to be emitted and detected on the other end, and that proportion will be analyzed by the computer. As far as design achievables, we believe a 20% waste reduction would be a very realistic and very effective solution for companies. One of the options that we discarded was instead of having the scanner scan for a multitude of various grocery products, whether it's dairy or meat or otherwise, we wanted to narrow our design to just scan for fruits and veggies, and more specifically, a certain type of fruit. And to review what everyone has mentioned in various ways, this design, it will have universal use. It's something that is widespread. It will be applicable in any grocery environment, and it won't interfere with the human element. And this, because this is an academic study, we're going to be effectively avoiding patent infringement. And lastly, we're approaching this project with transparency. Thank you.